All right, so the first thing that I need to show you is that the distance across a perfect square is not the same as the distance across, horizontally or vertically across. So if I were to take this arrow that measures the entire length of the square and then take that same arrow and rotate it diagonally, it doesn't reach all the way across. So the distance even across a square, or that is the base of a square or the height of a square, is not the same as the diagonal distance across a square. We need to know that because when we're measuring diagonal distances on the coordinate plane, we cannot count this length as one. This is one, if this is 1 unit, and this is 1 unit, this is not 1 unit. This is actually the square root of 2 units, right? Using our Pythagorean theorem. So for this problem, we have the points -2, -4, and -6, +3. Because we're measuring diagonally, not straight up and down, again, we can't count our bunny hops diagonally. We can't do that. We can only measure vertically and horizontally. So we have to create our right triangle like that. And then using our horizontal distance and vertical distance between those 2 points. Then we want to measure our legs. So this bottom leg, the base of this triangle, is 1, 2, 3, 4 bunny hops. And the height goes from -4 to +3. So that would be 7 bunny hops. Okay, -4 to +3, -4 to 0, and then another 3 to +3. Then in order to find the diagonal distance, that would be the hypotenuse of our right triangle that we created. So we know that a squared plus b squared equals c squared. So it would be 4 squared plus 7 squared equals c squared. So 4 squared plus 7 squared plus 7 squared equals c squared. So that means that c squared is equal to 65. So c, our hypotenuse, would be equal to the square root of 65, which is 8.1 rounded to the nearest 10. So 8.06 rounds to 8.1. So that would be our hypotenuse.